5.2, we're going to talk about direct variation, okay? And what direct variation is, it says that y varies directly with x. What that means is you don't have to add or subtract anything to y to get to, or to x to get to the y. So you have something like this. Y is equal to something times x. You don't have to add or subtract anything. Okay, so what a constant of variation is, it's this thing right here that we're multiplying x by. So a constant of variation is what we multiply x by. How we denote it or write it with direct variation, 5.2, we say y is equal to kx. And what this k represents is a constant of variation. Properties of direct variation, we have y is strictly dependent on x. That means we're not adding or subtracting anything. There is only x and y involved in an equation. That means I have something like y is equal to 3x, 2y is equal to 7x, 0 plus 6y equals 5x. Those are all examples of direct variation because the only things that I have is a y and an x, a y and an x, a y, oh this should be 5x, and an x. Now I don't care about this 0 because 0 always disappears. Another property of direct variation is we will always go through the origin on a graph. That's because we have the point 0, 0. If we have y is equal to some number times x, well, when x is 0, then we're going to get k times 0. So then you're, of course, going to have 0 equals 0. So how that would look, if we had a graph like this, and it would be varying slope. Sometimes you might have a really gradual slope, but as long as it goes through the origin, it represents a direct variation. We're gonna identify what represents a direct variation or what doesn't. Looking at this 5x equals 6y, do you think that's direct variation or not direct?
Direct.
Why?
Direct.
Why? Because it only has x and y. Is this direct variation or not?
Not direct variation.
Because it has a 4.
Because it has a 4, it doesn't just have the x and y, right? 4y minus 3 equals 8x?
Not direct.
Because we have this negative 3. 0 minus 7y equals 4x?
Direct.
Yeah, because the 0 disappears and we're left with just, the 0 would disappear and we are left with just negative 7y equals 4x. So that's just an x and y. That's the only things involved, right? 6y minus is equal to negative 3x?
Direct.
Why? Why?
X and Y.
Only x and y involved. 9x plus 3y equals negative 1
Not direct.
because the negative 1. The biggest thing that we want to do with direct variation equations is we want to always translate them. That means make them into this form, y equals kx. That just means that y is alone and we have some number sticking to x. The other important thing is that the y is on the left-hand side, the x is on the right-hand side. So the first thing we want to do is make sure y is on the left side. If not, move it. The second thing, we move the x term over if needed. You don't always have to. And lastly, you divide through by what's in front of y. So let's do an example together. Keeping in mind that I want it to look like this. Y alone is equal to something times x. This is just something. It's our constant of variation. What it's really going to represent is a slope, but we'll learn that 5-3. So if I had, let's start easy. 3y is equal to 6x. I want you to write that in a direct variation form. All right, so I see here, I check my steps. The first thing, I make sure y is on the left-hand side. Check, it is. The second thing I'm going to do is make sure that x is on the other side. Yes, it is. And the last thing, I divide through by what's in front of y. This 3 is in front of y, so I'm going to divide both sides by the 3. Now I get y alone is equal to 6 over 3 is 2x. And what you need to be able to specify is that this is your constant of variation. They might ask you to find k. If we ask you to find k, that just means what's in front of x, okay? If you have to find k, it just means what's in front of x. All right, I want you to do one like this. And this is a little bit more advanced because it looks like, maybe it's not a direct variation, but what really happens to the zero class?
It disappears.
It disappears, so it is a direct variation problem. So you just go through and get y alone. So the first thing I need to do according to my steps is make sure y is on the left. It is, I don't have to do anything. The second thing I'm going to do is move my x term over. Well, this is like a positive 4x, so to move it, I'm going to subtract 4x. So I'm left with this. I'm left with a negative 5y, right? Negative 5y is equal to a negative 4x. Now I need to divide through by what's in front of my y. That's the 5. So I'm going to divide both through by a negative 5. And y is equal to negative 4 over negative 5x, which is equal to 4 over 5x, because the negatives cancel out. So that 4/5 is the constant of variation. That would be the k in front. The other application of direct variation is related to graphs, and that a graph, if y varies directly with x, it's going to go through the origin. Does that represent a direct variation?
No.
Does this represent a direct variation?
Yeah.
Yes, this does, because it does go right through the origin. What I want you to notice, sometimes, looking at this one, since it does go through the origin, well, I just moved it, it is a direct variation. One of the things that I want you to notice, they're going to say, if this represents a direct variation, what is the slope? And when we find slope, that's connecting 4.1 step. When we find slope, we look for some perfect points it goes through. So it goes through that point, and it goes through 0, 0. And then I would identify the slope as rise, what I went up, over what I went over. Rise over run. Because we think slope represents steepness, how fast my height changes. So here it looks like I went up 1, 2, 3, and I went over 1, 2, 3. So my slope is equal to 1. You're going to find, especially in 5.3, you're going to find that slope is directly related with our constant of variation. The next application of direct variation is finding constant of variation given a point. The first thing you want to do when you are looking for that, you want to identify what your x and y are. So they're going to say something like the point 3,1 lies on a direct variation line. what is the constant of variation? What is that k? So you're going to have to find the point, find your x, y. So I have x is my 3, y is my 1. And then the second step, I'm going to have to substitute my x and my y value into this equation. We've been working with that plenty. So I'm going to say my y is 1. 1 is equal to whatever k is times my x, which is 3. So I say 3k. Notice I'm not going k times 3. We want to keep, when we times with variables, we want to keep things as a coefficient. We always want to put the number in front of the variable. Now the next step, I need to solve for k. So that means I need to move that 3 and get k alone. So if I have 1 is equal to 3k, well, to get k alone, I'm going to divide through by 3. So I get 1/3 is equal to k. That's my constant of variation. Lastly, I have to rewrite it in y equals kx format using our new k. So I just write y equals 1/3 times x because I solved for k. The k is that. And I plug in, just put everything else there. We're going to do an example. And I have a line that represents a direct variation. And the point 6, 7, let me make 6, negative 4. The point 6, negative 4 lies on this line that represents direct variation. I want to find my k, my constant of variation. My first strategy right away, I always like to write this because I just want the formula there. I'm always working with this formula. The first step is to identify my x and y. Well, this is my x, of course, that's my y. And then I'm just going to plug in. So I have negative 4 is equal to 6k. Okay, the next thing I want to do is solve for my k, solve for my constant. So this is saying 6 times k. In order to move times, you divide. And I have negative 4 over 6 is equal to k. I do want to simplify this fraction. 2 goes into both of them. So that turns into 2. This turns into 3. K is actually equal to a negative 2 over 3. My last step, what many students do, they get to this point and say, yay, I'm done. Not done yet. You have to go back to this formula, y equals k times x, because now I have my k. So now I go back and say y is equal to negative 2 over 3 x. Now I am done. And that is my direct variation equation. So I just made the equation of this line. All right, sometimes you're given a table and you're going to be asked to write the direct variation equation from it. The steps behind it, you want to first pick a point. Reminder that when you have a table, you're given a bunch of points. This is a point, that's a point, that's a point, and that's a point. You need to make sure to pick a point, but you cannot pick 0, 0. Because you will never find out what k is. Because if I did y is equal to kx, and I plug 0, 0 in, you get 0 is equal to 0 times k. Well, it could be anything. That didn't specify anything to me. So you want to make sure that you pick a point that is not 0, 0. And then you find k and write the equation. So looking at this one, this table, I'm going to go ahead and pick 10, 4. All right, so the point 10, 4 That's my X, that's my Y. Of course, you don't always have to do that. I just do that to help while I'm teaching you something new. Now I'm going to plug it into the equation y equals kx. So my y is 4. 4 is equal to, I don't know k, but I know x is 10. 10 times k. Now I'm going to move that 10 by dividing both sides. And I get 4/10 is equal to k, which simplifies down into 2/5. Now that last step that many of us forget is to put it back into that original equation. And we get y is equal to 2/5 times x.
Ow.
Your homework for tonight is going to be page 302, problems 1 through 20, and 27 through 29. I also want you to do, these are really good problems, 36 through 39. So you have quite a little sectioned off parts of the homework. It should go good.